In this video, I would like to build with you this plastic dining chair of Charles Eames. What you see here is the SketchUp model I downloaded from Herman Miller. So I have an accurate three-dimensional representation of that design, so I don't have to work with blueprints, but rather have a 3D model. So we can use this as a better three-dimensional blueprint. Okay, so what I will do first is I will move everything so it is nicely centered as much as possible. At least from the front, and maybe let's take a look from the side, because that's important later for the doll base. Because there are a lot of elements we only have to build once, and then we just replicate it. Okay, so let's start with the seat. Similar to the Pantene chair, we know this is actually a very simple object. So I will maybe add a plane, move this plane up, and then in edit mode I will scale this plane down. Let's double check that the object X and Y is all 0. It is. Perfect. And then maybe I can go to a side view, select all these points, E, and move them up. This, for example, goes to there. This one goes to there. So here I will work a little bit based on the front edge. We actually know that here at one point we have to bend it back. So I will extrude it twice. Plus here I might need a loop cut, there maybe as well. And we can also remove half of it. So let's add a mirror modifier to the correct direction, there, and a sub D modifier. Okay, and maybe let's take a look at the side. Oh, we actually close. So this one maybe a little bit more up. This one maybe to there and there. Then we have to see how high we have to push this one up to get kind of like that curvature flow we are looking for. But I try not to spend too much time on perfecting it, because later we have to extrude the sides down and then everything will change anyway again. Now here we have a perfect midpoint representation. So there you see how I can move all these parts down. Also here for the back. This one has to go in a little bit. And I see here it dips in at one point. So I might have to add later another loop cut. Okay, but before I do this, let's maybe take care of this part here. This goes in, this goes in. So there now I have to be careful that I do not, how could I say that, move these points so I get snake lines. That should be nice and linear. So maybe in a top view, let's take a look. That's okay so far. Maybe this can go forward a little bit, and there I can see that this is not ideal. So maybe a little bit to there, a little bit to there. Okay, yeah, good. So there's a little bit of geometry that goes back inside this model. We don't really see it as good, but when we go to Chrome and type in Eames dining chair molded plastic, and let's take a look. I would like to see something from the side, maybe there. Oh, that image is too small. Well, actually here indeed it is sharp. But I would like to do rather more something like here, where it maybe goes back a little bit. Maybe there you can see it a little bit better, that rim. So that would be the same technique as we did before with that other chair. So, however, I would like to have a perfect, how could I say that, offset of this point going to different directions. So I will, in this case now, not select this one, E and extrude and then hand model it. I will actually do this. AA, Control N to make sure all normals are correct. And then, for example, I will type in spacebar, solidify, and do a solidify command. And then I can move this one maybe away a little bit, memorize the value. And after I did this, I select all these internal points here and then simply delete it. And then you see we created a small even rim around it. So there's a little bit of cleanup work we have to do. So this one has to go along this axis and then here the same and snap and there. Nice little lip. So looks like this is maybe not as big as I wanted. So 0.2 was not enough. So maybe let's do this again, solidify, but in this case, no, maybe. It's always easier to actually make it bigger. Let's do this, and then we can slice it down to what we need. It's always more difficult to make it too short, and then you have to adjust it. Let's clean up the seams here. Okay, so there now, you see this is maybe a little bit too big. So two ways how we could do it. Control R, make a loop cut, and then we can slide, for example, it to 0, so 50%, and then we can select the outer edge and discard it, and then now we have half the size. Okay. And then in addition, we could go ahead and maybe fine-tune the distances and maybe perfect them a little bit. Maybe this should be a little bit lower, based on how you want to do it. So let's show Shift 1, the other part, and there we see that everything grew a little bit too big. So this one maybe now we can move to there. This including the edge goes to there. This one goes to there. So you see now I will always move everything including the edge I created. Then this may be down and down and down. So I mentioned before here I will need to have an additional loop cut, so I have to do it. I don't really like adding too much geometry because it adds too much work or control points, but in this case here I need to. And as it looks, all those are too far apart, so I move everything together at once. Maybe this a little bit higher. And then this one maybe a little bit to there. This maybe, let's see, a little bit inwards. Yeah, okay. There, see. We're getting close again. Okay, let's take a look what we have. Looks like a good shell. Besides one thing, I can see that this point dipped in a little bit. So what are now ways or techniques to clean this up? Well, if you want on purpose, sorry, something to bend in, not a big deal. However, if something should be nice and flat, so linear, then there are multiple ways how we could do this. So because we work on half a model, in object mode, I simply will add a nice big plane. And let's see, I'm going to laugh in case this is actually flush, and it's just the topology fooled me, and wah, wah. Our model is actually okay. So the shading just looked like it was off. Yeah. Okay, well, good. Perfect. Because otherwise, let's say this would have been too far out, then I could use the plane to make sure that these points are all nicely lined up and creating a wall. So this should be a shell and not just paper thin. So also here we can give this maybe like a thickness. I'm 100% sure here we can go to the inside because it is not very sharp. And for render purpose, I will add another subdivision at the end so that these ends here will round a little bit during render time. There's, one extra. This is nice and round. Otherwise it would look flat. Okay, so I would say that shell, at least for the moment, the way how we have it, is good. So let's save this first. And let's call this one Eames dining chair wooden dowel base. So if I compare the original shell with what I did, we are pretty close. The only difference or issue is there are some differences in the center part, which I'm not really very fond of. So let's fine tune this design a little bit more. First, actually, these side edges here I will lift up a little bit. Maybe there, and then they I push out a tick. Okay. Let's take a look at the back. Go up there. Okay, so good. Now the question is, how do I maybe how do I get extra geometry in there? And well, I have to do now and add geometry. So Control R and add a loop cut. There. Problem is, when adding the loop cut, as you can see, I might have to adjust then the whole design later afterwards because I added more stuff to it. Now I have to fine tune the positioning, and for example here now this dips down way too much, but if I bring this one in and maybe bring this one out, I'm close actually to my original shape back, and with more points I can be a little bit more specific in certain areas on the other side. So it's actually not too bad there. So let's see how this compares to the original shell. This is maybe dipping down here a little bit too much, and this is also in my design flat. Here it is arced. So maybe I will select these points and try to arc it a little bit, and then maybe there and there. Yeah. Okay, so a little bit of cleanup. Maybe those can go to there a little bit. Not too much, so that all this is a nice flat C. You do not want to see something that clearly pinches here more. Okay. Maybe a little bit there. Yeah, and there we are. Okay. Good. Okay, so why was this actually important to fix? Because in this next step, we will take a look at how do we connect, for example, the legs to the seat. And the technique there is simply that you create those, cone shape volumes added to the seat shell for injection molding, and then we have hard points we can drill into and mount actually the undercarriage. So maybe this is something we should first put into our model here as well. So let's see maybe how this could work out. I will turn back on my solidify modifier there, so I have some thickness. And essentially those are circles we can extrude, and then the second extrusion we scale, and then we fill the faces. So let's do that. Step number 1, I will make sure that my 3D cursor X and Y is 0. Okay, circle 8, 1 centimeter. Let's add a sub D so we can round it. And then I move in object mode the part to there. S and Y, scale it down to maybe what I need. Okay, let's go to side view. And then in object mode, I can move it down to there. And then this mid part, I move down. Okay. So this is actually pretty close. Then I can F to fill it, select this loop and fill it, and then Shift E and 1, and this loop, Shift E and 1, and crease it. There. Okay, perfect. So we have actually 4 of those. So this maybe, let's see, we can rotate a little bit and move it to there. And then let's see, when we Alt D, move this one to there, and then we can go to local mode, move this one up, and then maybe try to use the different views to position this correctly. There, looks like it has to be rotated a little bit more. Let's go to the rotation tool. Now finding the correct view is maybe a little bit tricky, so maybe something like this. Yeah. Well, we just block parts out for the moment, slightly. So there maybe. Okay, well, we can leave it there for the moment. So 2 we have done. We show our shell. We can simply use the shell as the mirror part. So mirror along the y-axis, along the shell, and then here we do the same. Whoops, there, and y. Okay, at least now we have a quick position of those hard points. And I also leave it for the moment at this rather basic design. That's fine. However, I will take one, Alt D, and move it to somewhere else, and then I turn this one off, and I set everything to 0 because this is my masterpiece. So when, for example, I go in and change this one, you see the others will update. Okay, good. Now we can take a look at maybe the wooden dowels, how we could build those. So those are 4 parts, and they're rotated inwards. So as you can see, it looks like a perfect square base. So what would be the best idea? Well, if we hide actually also the rest and then only show the metal part, we can also see that there are actually metal parts added to it. And these metal parts are perfectly stuck into them, and then we cut them out. So there are 2 different strategies. I build everything in 3D space and then model it the way how it should be, or maybe I build parts so they're nicely rotated or aligned along X, Y, and Z, and then a group I rotate into the position. And that's probably the approach I will use. So first, I will just create myself again another circle and maybe extrude this one down a little bit. Yeah. Okay, and then I will move this one to there, kind of like eyeballing the center. And maybe down to there. Okay, and then this one can go further down. Actually, Shift E and 1, select all these points, Shift E and 1, and then Control 4. So we have a nice rounded cylinder, one loop cut at the center, GG a little bit up, scale a little bit out, and there's our wooden doll. Okay, so why did I put this one actually to the top and then extruded it down? The main reason is, as you can see, the top of these wooden dolls aren't cut, only the bottom part. So this is a flush surface. So for me, this is actually ideal to work from there. And this is now the step I would use. First, because this is rotated 45 degrees, I can rotate this one 45 degrees along the z-axis. Okay, and then I can use the y and rotate it along the local y-axis. Tail, for example, it perfectly fits. You see now my x is not touched, only y and z. And this can be very useful for certain reasons. First, let me isolate just this leg, and then the rest I hide. Okay. So what's this? Yep, that's my model. First, now I can try to fine-tune the position. There. Okay, good. And then let's take a look at the bottom. Is this maybe centered? Yeah, more or less. Let's say 21 degrees, 22 degrees. Okay, what I had before seemed to be good, so 25 there. Okay. Then we can actually, in local space, scale this one till, for example, it hits that point, go maybe up a little bit. Okay, so I'm not sure if this is maybe the correct size, so let's make this a little bit bigger. This may be a tick smaller. Yeah, there. Okay, perfect. So you see that this way I quickly rotated the part into the position I need. And now how do I do, for example, this metal bracket? So with metal bracket, I'm talking about this part. So let's isolate it. Let's hide all the rest there. Because now the question is, how do I construct this one so it looks nice and clean, has exactly the same horizontal flatness, but what I want is that inside the pipe it goes in nicely, so it's tangent to the wooden dowel. So there are a few techniques now how we could do this. Yeah, that's actually the way how I will do it. So where is my part? There, that's my part. Cursor to select it. Okay. So Shift A, add a plane. In an edit mode, scale the plane simply down. And what's this? That's my SketchUp model. There, it's gone. Okay, good. So this one I will fill. Okay. So this object, and then I click this object. I will copy, right mouse button click, copy to selected. And now you see this plane got rotated exactly the way how this object is rotated. So because this object is rotated, I can then go into edit mode, throw everything else out. This maybe for the moment I keep at that size. Okay. So because I work now in local space, I can press E and then Z and second time Z, or press E, escape, and then move it down. Let's do this one more time. E, Z, Z. Oh, it doesn't go local. Okay. E, escape, and then G, Z, Z, and then move it up. Perfect. Good. So, let's see there, and then maybe that's now the tricky part. How do I bring this one over so it is perfectly horizontal? So E, escape, then I move it along the x-axis, but because this object is rotated, you see it goes straight down. And now I can simply press G and Z and snap to the height. There. Perfect. Let's add a solidify modifier. This is roughly 3 millimeters, I think. Offset 0, so it grows 1.5 millimeters each direction. Yeah, okay. Let's say this is pretty close. Good. This edge I will bevel weight, because here we have to simulate that this is actually rounded. So maybe 1 centimeter, 10. This is pretty simple, not a big deal. Only along edges that are weighted. So maybe 0.75 centimeters. Oh, 5 millimeters. No, 6 millimeters. 7 millimeters. That looks like it. Okay, and maybe 0.6, so it's a nicer bend. 0.7, not so boring G1 tangent. Okay, let's take a look at what we have. And you see this is actually a nice and clean geometry. So this metal part grows out of my wooden dowel exactly parallel to its internal axis, or perpendicular onto the cap surface. And then this part here is flush and horizontal. Great. So here's a nice, neat trick now. So essentially the wooden dowel is the important part. So I can actually parent this metal part to the wooden dowel. So we call this one, let's say, leg. And then this is maybe leg metal bracket. So when I select this one and at one point maybe say, nah, make it all 0, you see this metal part then rotates with it. Pretty nice. Okay, good. Let's select everything and move this maybe onto the 3rd layer. Also here, those I move onto the 3rd layer. Let's take a look at what we have. Yeah, now we see already maybe some future issues. So maybe at one point we have to make those cones a little bit bigger, and then we have to horizontally flush the caps, or we have to mend the metal parts. So we'll see what we will do. Okay, but the wooden dowel isn't finished yet, so this bottom part we have to cap. Okay, and now you see the way how this looks. So the question now is, how do we want to finish this? This is not really ideal being that strong at an angle, but maybe let's see. So if we set our 3D cursor to there, and I will import my quad ball. So let's go to my Google Drive. Let me see where. Oh, there's a folder, and there's a quad ball. Okay, there. So here's the part that's way too big, and let's scale this one down a little bit. Ooh, a little bit more. Should not scale too small. So that's inverted, and then maybe Shift S selection to cursor, select this one, and then copy to selected. And you see now I scaled my quad ball to the rotation. No, not I scaled. I copied the rotation values of my quad ball so it matches the wooden dowel, and then I can scale this one down maybe till, let's say, something like this fits. And maybe a local movement, and maybe move this one up or down. And for the moment I simply keep it there because I'm not sure yet how I want this detail to work out. So ideally this idea is that this is like a hard plastic part which we then can screw or attach to the wooden dowel. And then we would have this area to be where it contacts with the ground. Okay, good. So I actually would like this one to be mirrored now. So what I will do now, I could use the shell, or what I will do instead, because at one point in scenes I would like to be able to move a complete chair around. I will set my cursor to the world center. I will add a single arrow. Let's say I call this one chair. Actually, I will say chair parent empty, so it makes more sense. Okay, good. Size, well, maybe 20 centimeters. Doesn't have to be too big. So what's this empty actually useful for? Well, it has two functions. First, I can use this with the glider and mirror it. So let's say you mirror along there and there. And you see, while my object has its local orientation, it fetches the orientation of this empty to mirror it along the ground. Perfect. I can actually do the same with the wooden dowel. So select the sphere, Control L, and say just copy my modifier stack. Zip, there it is. So when this one goes to somewhere else, you see everything moves with it. Okay, perfect. The second function later, we can use this empty, and then we parent everything to it, and then when we move the empty, the complete share, all these parts will follow it as well. Okay, so let's take a look at where we are. So we have a little bit the back part done. This actually, we can also give the mirror modifier and along the y-axis actually. There. Okay, good. So now the tricky question is, how do we do actually the same with the front part? And we see that the distance is quite different. And also here, if we go back to the original shell, you see this actually is somewhat different. So what we will do now is simply the following. So this one we can hide. And let's take a look. So this is maybe number one, and then Shift D. Let's move this one to somewhere else. And yeah, we have to move this one to there. So how do we do this actually? Because I want that to perfectly fit that object there as well. Yeah, so that's actually what I will do. I will modify this a little bit by simply only having this orientation. Okay, and then this one here, Control Alt P, clear parent. Okay, and there we do an Alt D. So it is actually a clone. And now I would like this clone to be on the other side. So I think I can rotate this one simply over to there. So these are roughly, yeah, minus 90 degrees. So R minus 90. Okay. So you see only the Z orientation got slightly changed. So that is okay. And now Shift S, cursor to selected. So you see it goes back to this point, and then there, selection to cursor, and this is 135. 135. Dang. Okay. So, but the problem we see now is that it doesn't really actually fit the design. So shoot, what do I do now? Well, first, let's actually parent this one to my leg, and then maybe we can see what we could do. First, let's take a look at what we have there. So they actually oriented to there. So this metal part basically might simply only have to be rotated a little bit around its z-axis. So R, Z, Z, and 180. So you see now it looks actually to the other side. Perfect. And now I can select this and, for example, move this one up, and then this one I move along this one down. And there, select both, and then again local z-axis, and for example move it out a little bit. Okay, good. Not too bad. We will see actually that this part is not perfectly centered over our metal part. So, how do we do this? Well, we could go into a top view and, for example, and here, maybe simply position it so it is above it. Let's take a look how far this is correct. So, yeah, that seems to be pretty close. Little small trick, what I will do, I simply will add a center loop cut, E and X, and then I, along the local direction, move a plane out. I will turn solidify off, because the main reason for that was I have kind of like a mid plane, and now I can see if this one maybe sits on it, and it seems to. So just wanted to better check if these parts are centered correctly. So nope, maybe one more down. Yeah, okay, never mind. I can throw this out. No, I don't need it anymore. It was just more a small placeholder. Okay, good. So I would say these objects seem to be pretty well positioned. But how do we now add this actually to the shell? And the question now is, do I want to trim these cones, and then how could I say that? So I trim the flat shorter parts and then let it grow into the shell. Or maybe if at this point now I maybe think about I will restructure my approach and I build small circles where actually it touches the metal bracket and then they just grow into the shell and the shell then trims the shape of the cones. Because I kind of like the way how they are flush with the metal part. And you see here, there it is not, so that's not ideal. So I might have to change the way how I build actually these cones and then restructure it a little bit. So for this, actually, I will add this loop cut there again, which I have, and then also there at the midpoint and there at the midpoint, because then I always have a center point. So Shift S, cursor to selected. Perfect. So why did I do this? Well, this part here, Shift D, I will make a copy. And then, well, this is my loop. I select it, cursor to selected, object mode, and then I will reset my pivot point to there. Because now I can select this point and say, hey, you go to where my cursor is. Perfect. So first thing is I built this one so these parts are flat. I don't know necessarily if that's what I need. Let's show actually our shell. And oh, maybe we can keep it this way. I could also rotate this a little bit, which means all this part has to go down a little bit as well. This is such a minor part. I can also simply do it this way. So this part is perfectly centered on the part, and then you can see how it grows into the shell. Okay, so here, cursor to selected, and then this one, there I make a clone, Alt D, move it to somewhere else, Shift S, selection to cursor. The problem unfortunately now is how do I rotate this one? So this is now where actually the parenting and all the stuff comes in very, very handy. So first, let's see if this one we copy and set to 0. It looks like this. Yikes. I was curious if this actually might be flush. It is not. Okay, and then let's set this one to 0. Cursor to selected, and then this one here, selection to cursor, Alt H, oops, Shift H to hide the rest. And for the moment, I turn this one off and this one off, and let's go into a side view. At least from a side view, it's very easy to rotate something there. So maybe is that the correct amount? Yeah, this seems to be very, very close. These are two different parts which will be screwed together, so I can zoom in and then simply rotate the parts. Okay, that's good. Now I can bring my solidify modifier back. This one I can now move up and then snap to the mesh. And this part I will parent to the metal bracket. Main reason is if I move now the metal bracket, this part will follow it. Shift H to show everything, and then U to U. Please copy the rotation, and then okay, we get something like this. Oh yeah, this one should be rotated 90 or 180. RZZ 180. There it is. Perfect. Okay, so what do we have here? There we have some old parts. They all can go. Okay, good. So you mirror over, and then this one we will give a mirror command as well along the y-axis there, and the same with the part down there. And we can just throw that piece away because we don't need it. That was an older part. So you see that how I decided to change the way how I create and structure my design based on maybe later what will be easier for me than to modify all these parts. So now I have everything nicely lined up. That seems to make sense. Okay, good. So I noticed actually that this one, while I mirrored it, doesn't fit perfectly. Okay, so how do I fix this? Well, the thing is, obviously I cannot mirror it along both directions, so maybe this one will go only along X, and then Alt D, so I make a copy of this glider, and then here I will Shift S, cursor to select it, and then you snap to that position. And because I made a clone, they are linked geometry wise, but they have their own unique mirror commands. So this fits perfectly now. Okay, good. Because they are, as it looks, also not 100% exactly the same height-wise, or not height-wise, left and right. You see, like from the front, there's a little bit of an offset. So I needed to take that into consideration. Okay, so we're pretty close to wrap this up. The last piece that is missing is actually this metal construction here. So, talking about this metal construction. Whenever we create a CAD model for injection molded parts or something, or even if it's flat wood and we CNC something out, we have and we should be very precise inside our digital model. So if we pass this over to an engineer or the manufacturing department, they understand how to, let's say for injection molding, how to make maybe a mold and then test it. But with stock material, let's say metal rod or pipes, which during the manufacturing process we don't injection mold, but we just bend and then trim, drill, pinch, compress, hammer, or squeeze. There is a different process during the prototyping phase. We would just make hand pieces and try to see how it perfectly fits. In the CAD model, we can give some suggestions, maybe where it should be and how it could look like. But for example, right here, you see these two wires are built so they intersect. In real life, that doesn't happen. So one has to be a little bit smaller, or one will be a little bit bigger. And this type of dimensioning and how much metal you need, we will fine tune during the prototyping phase. And that means that inside a computer model, we can either trick around a little bit like this, because if we would add really naturally bent pipes, that it looks maybe for rendering more perfect, but the engineer will not take care of the information how I bend pipe, because they will simply take their own tools, bend it, and then they have it. So, meaning again, to summarize this, for really accurate rendering, well, we could simulate the way how material might deform or so, but for manufacturing or so, that's not something we have to put into the CAD model. It might actually be rather too much information. Okay, so how do we build this part now? Let's take a look at an individual element there. So it looks like this is a part they have, and then there these parts overlap, and then they drill it together. So this is, for example, here one of these parts. What I mean, so also here they intersect, so one would be above, one would be below, and then we just put the screw through. So that means now we could maybe make a rather simplified model. What would be the most efficient way to build this? Let's take a look at our legs there. Okay. Good. Yeah, maybe let's try to do it this way. I set my cursor to the world center, and then I will reset this object's origin to there. So Control A rotation. If I rotate this one -45, I have it nicely lined up. So this, for example, will be very helpful for me now to use as a guide. And because I lined it up with the world, instead of being rotated, it is also easier to model. So there's some piping that goes up, and then there are flat parts. So that's actually pretty easy to build. So cursor to selected. Let's make sure that maybe all this is at 0 and this is compressed. Yeah, we can simply do it maybe this way. R and X, let's rotate it down. This goes up. This maybe goes a little bit shorter. Control R. There and there and there, there, and then maybe here, here, here. E, escape, S and X. Let's scale this one out, and then this one maybe move up, and S and X. Okay, so something like this, and then let's bring it to there. Okay, so and essentially this part maybe might be in the center here, and then I will just rotate it for the moment, maybe so it looks like it is flush. Okay, and this part local, maybe move it up a little bit. Okay, let's see what thickness this might have. Maybe 3 millimeters and 0. Yeah, okay, good. So then we have some sort of extrusion that gets out there. So in that case, I will just work with a cube, stretch it out, and maybe put it to there and rotate it. There, SZ, so I scale along local space, and there. Okay, and then maybe top view, move it to the center, and then rotate it. Wah, wah. Yeah, we're getting close to it. Okay, maybe let's turn this one on for the second, and there. There, okay, good. And then let's see if we scale this one a little bit more. There, and we go maybe into edit mode. You see, I'm just simply trying to get an idea maybe where my building blocks are there. Okay, good. And then we have the small metal bracket there at the end. So another part. So Shift A. This is smaller, R, Y, and 0. Let's go to the side. Maybe rotate it into the shape we need. There. Okay, looks like this has to be also rotated a little bit to there. And then, yeah, we have to rotate it there. Let's take a look how it feels there. And maybe bring it down. There, yeah, okay. That's close. And this piece properly also has 3 millimeters of a solidify modifier. Let's make sure there's no scale factor applied there. And this should be 0. Okay. And we move this one there. And I'm not sure if maybe like this. Okay, doesn't have to be too crazy. Okay, so we have a very simple set here, and you can start maybe seeing why I did this. So you and you, I will actually parent everything to this part, and you and you, let's go to mirror along this one, and you mirror also along this one. Yeah, okay. So because I think this one I have to rotate back, simply 45 degrees. So let's take a look at our legs. Rotate minus 45. Yep, so minus 45 there. Okay. And there we see how it might actually fit. So, close. So there are now actually different strategies how maybe we could do this. So this one I pick and say cursor to selected, and then there say origin to this part, because now seeing where the metal part is, I can simply move this one, let's say to there, and maybe a little bit further to there. Okay, maybe add a little bit more. Now I'm curious if this rotation wise fits good. No, it does not. So I can rotate this one maybe a little bit, and rotate along, please, your own center point. So now I see I rotated this one flush a little bit to that base. So let's take a look here. Oh, this is a little bit too far away. So let's move this one to there. And all those, I will actually Alt P and say clear parent, but keep the transformation because they're all in position right now. Because I want to position all these elements here now individually. And this has to be slightly rotated. Okay. This part is okay. Good. Yeah. Nice. Okay. So for a moment, let's go back to here because I want to double check something. I always have multiple elements here. Where's that other part? Oh, there it is. Okay, good. Yeah. So what I will do now is this is actually just my visual structure, how something could look like. It shows me the metal parts at the ends in the center, and then also the maybe where the tube could be. And now I can try to see how I could build a geometry based on that. So you and you and you, Shift D, escape, and M and 5, so I put it onto a different layer. And then you apply, please, the mirror modifier. You apply it. So now I have this thickness. And then you and you join. So Control J. See, now I could, if I want to be quick and dirty, and say this face to this face fill. So with a bridge command, bang, they have a connection. But that's not really the rod structure I want. So if I take a look at this one here, so maybe this has to be rotated a tiny bit. So Shift S, cursor to there, and then seeing from the top, I will switch to 3D cursor rotation and rotate this a little bit more. Let's say there. Okay, so this might actually make more sense now. Okay, so and then this one, I also join to this. Dang. And then I could say 1, 2, 3, 4, 5, 6, 7, 8. And say bridge. Okay. Are there any faces in the inside? No, they're not. Good. And then you and bridge. And there I have now that metal construction I was looking for. Going to edit mode, AA, Control N to clean everything up. Now this is actually not round, so we could actually add a subdivision surface modifier. So for example, it looks roundish. And then the rest here, for example, let's say this is all metal we tighten or we sharpen. So we could, for example, add, as you can see, some loop cuts to it. There, so we could simulate the way how it looked like in case this would be all square rod, and then we just with a hammer under a machine flatten it. So then here we add also some loop cuts to, for example, sharpen this a little bit. Also here, these edges I select and then pinch this a little bit, maybe the same there. Yep, and crease. Okay, actually this one we don't need because we can add a mirror modifier before we do the subdivision. AA, Control N, AA, shade smooth, and maybe we could add an edge split just for the quick rendering effect to see creased edges. Okay, this is not too bad. I don't know if I like those edges to be sharpened, so maybe I make it rather round. And this will be an internal structure anyway. And this is again now a piece where it's really, how could I say that, the way how this will look will later be decided by the machining, stamping, etc. So I can simply build something like this so that it looks similar. and that this part somebody can later take and then make a masterpiece out of it for the prototyping. Okay, let's see how this one fits into our design. This is actually not too bad, so that's nice. So, and now comes actually the tricky part. How do we replicate the rest and also do it in a way so that it will look more fitting? So I'm curious about the following idea. So I will set my cursor to the world center, and then this part here I will Shift D, escape R 180 and rotate it to the other corner, because as you can see now this doesn't fit. So I could, if I want to make it quick and easy, leave it this way. I could also select number 1, 2, 3. Yeah, so that's the way how the design is done. So I can select these two, Shift D, and then around the 3D cursor R90. Yeah, there we are. See? Maybe show the shell. Okay, and the problem is only this doesn't look very, very good. So let's see how we maybe could fix this. So essentially what I need now is number 1 and number 2, and then I can, for example, Shift D, R90, rotate them around the cursor, so around the world center. Now we see where they all perfectly intersect. Then I can go ahead and Control R, add a loop cut. And here's a little trick. Now you see when we set this to bounding box and normal, looks like the orientation is not planar to this loop cut because there isn't a face. But the moment we add a face, zip, this one lines up perfectly. So same here, Control RF. Here, Control RF. Control RF. And then we can bend this out a little bit and maybe be consistent with the amount. So maybe 2.7. And maybe here, kind of like inwards a little bit, and then there 2.7 was something. Or we could simply do this by trying to eyeball it, because at the end, if this is all metal, it might bend itself by compressing a little bit. So there, there. Okay. So this, for example, looks already a little bit better. So what do we do with these faces we have there? Maybe I will just in the loop cuts line them up to there, so they're all kind of like at the center. Move GG, obviously. So okay. So for example, there, this can be out a little bit, and maybe out to there a little bit. Yeah, okay. Yeah, so because those internal faces are not really ideal, we have to remove the faces then at one point. So, and then everything will snap back probably a tiny bit. Let's go into face selection to double check that there are no hidden faces we overlooked inside any pipe. Okay, Perfect. So you see now that this actually looks a little bit better. One pipe is in front, one is behind. I left it the moment so they slightly intersect based on maybe the manufacturing. Maybe we just actually drill or file a little bit metal away so there's a little bit of an overlap, and then we could solder it together to make it stiffer. Or maybe we compress it, we hammer an indentation into it, might actually be faster than just filing it or so, and cleaner. Or in case we do not want this to be connected with soldering or TIG welding or so, then we could just maybe bend these parts out a little bit further. I just left it this way for the rendering purpose because visually this is really everything I need to show. You might only see that something is wrong if I really zoom in that these parts intersect. And as long as, that's another tip in the rendering, something you do not see, you do not have to show. So, and then all this maybe I will put onto the third layer. And let's take a look with the shell. Okay, goody. This is all pretty close. The only thing maybe that's wrong is actually this part here. So that one has some definite issues. I'd like to take a look at those discs to see how far they go in. Yeah, so I need to fix that problem now. So what would be the easiest way in terms of designing this and making it better? So this is actually circle of 5. This is also circle of 5. Oh yeah, they are mirrored. Okay, so I can go to one normal and, for example, make this one bigger, which obviously will result that it will overlap. Okay, not a big deal, because what I will do now is simply the following. So this one I will turn off. Okay. And I want to trim actually those parts here. So how do we create the subdivision, the offset, so it grows to the one side? So if I set this to 0 and for the moment maybe turn this one off, Shift D. I'm just making a copy. I want to check something for the moment. And yeah, so it goes to there. Okay, good. Yeah, then this is the way how I will do it. I will double check that I do not work on my original shell. Okay, so one of these is now my original shell. That is plane and plane 0. So plane, that actually should be my original shell. And that goes back to layer 2. There, and you might ask yourself now what I was doing. I tried to create a surface that runs through the center of this shell. So I go with -1, and when I set this to 0, I have an offset that, as you can see, is at the center of my shell. So, and this is very useful because now I could go and say apply. Hold on, actually, before I do apply, I say do not fill the rim. So what's the rim? You see that the sides here are open. So there you can see how the surface is inside. So now I do apply, and then it's very easy to select the outside shell and simply delete it. And let's see if I need to adjust anything there. for the mirror, but everything is perfect. Okay. Good. Control N there. So this now I can use to trim actually these cups or cones. So you, because you're not very important for the rendering, I set you guys down to view of 2 and then Boolean difference, this one. Okay, that means this surface should be flip normal. Okay, so it cuts the other stuff away. So the other part is trimmed at the same time. So then here we add another Boolean command. And this is basically the way how I would work in Fusion as well. I would create myself this surface and then cut it out. And then now this object, for example, I deactivate everything for this so I don't see it in rendering, set it to wire. Woo, wrong one, wrong object. I meant to do this with this trimming surface. There. So now you can see that when I set this to shade smooth and then maybe auto smooth and 30. Currently it looks like they're perfectly flush or inserted. So there you see it slightly intersects. Now if I want to be, let's say, 3D print a basic shell as a demo, then this one has to be joined to the main shell. We can maybe do this moment for as an exercise. So there, this seeding shell we will add to booleans union and union. This is plane, this is circle. Might take a second, and then the same there. Also turn this on. So Blender in the shading breaks the edges for me. And then when I go back to this view and set this to 30, there we see now that this is actually one object with those cones actually added to it. So when it comes out of the injection molding process, we have actually solid hard points where we have volume you could screw something into. And this is the step to boolean it to it is really only needed then maybe for 3D printing or when this goes to the engineer for the conceptual modeling, because I don't really see this edge necessarily. I could also skip actually this boolean step for the moment. So the software runs a step faster. And the same idea also applies to Fusion. You see in Blender, the more boolean modifiers we add, the slower it gets. Fusion to a certain degree also is the same. The longer a design tree is, the longer it always takes for Fusion to update it. And the question is, do you need it? But when we go into Fusion, I will show how to do it there. So in this case here, what I will simply do, I will go into edit mode and for the moment simply turn this off. So it does not impact the calculation, but I have that function included, but they are frozen. Okay, I would say we finished the chair. There it is. Now there was one thing actually I forgot. These wooden dolls aren't finished. So what we will do first is we will add a bevel modifier and then 2 millimeters and then maybe 10 steps. but only don't fillet all these edges, just fillet sharp edges. So with the angle, you see that this is now nicely touched up. Maybe make this a tick rounder. So I can do the same maybe here as well. So bevel 2 millimeters, 10 steps, 0.6 profile along only the specified angle. Okay. And this Boolean modifier I will remove. Oh, does this not have a scale factor? No, why is this actually working bigger there? This is interesting. Oh, maybe 2 millimeters is actually way too big. So here, 1 millimeter. Yeah. Okay. Good. So this is something like in Fusion we would do as well. We have a very flat object, and then later we just round these edges. Okay, and then we will add a Boolean modifier, because this object now we will cut with the metal bracket, so we understand maybe where the gap is, where the bracket goes in. See, there. There seems to be also currently a small artifact happening. You see these edges here are intersecting. So to get better geometry, I simply turn this clamp on, which prevents edges that intersect. And at the end, this rounding gets a bit smaller, but it's fine, because in real life we would just take sandpaper and just break the edge. So it's not too sharp. And let's cut this part out. And also there now we have this part removed. So the order is actually pretty important. So we round first and then we cut this one out. And otherwise, when we would cut this gap out, it would try to round everything here. And this part doesn't really need to be rounded. It's just this part in case your fingers touch it, or down here when we lift the chairs. You don't want sharp edges to cut you. At the same time, they look unrefined and might also chip. So everything, when we round it, the wood has less of a hard edge. When we hit it, then it maybe chips off or flakes off a little bit. Okay, that's it.